When it comes to the topic of rises and falls throughout history, nothing really makes things rise or fall better than gravity. And no, I'm not talking about the masterpiece drama starring Sandra Bullock. I'm talking about the force that really keeps things grounded. Although it was widely believed throughout history that when you drop things they fall, modern work on gravitational theory really began with your boy Galileo. Galileo dropped the ball in the late 16th century. Well, actually, he dropped two of them at the same time and proved that objects of different masses fall at the same speeds. This also proved OG Greek philosopher Aristotle dropped the ball in a more figurative way when he claimed that objects of different masses fall at different speeds. Along with Galileo, there was this guy named Newton, no relation to the football player, who also helped with the whole gravity don't give a damn about mass thing. Newton also published the idea of Newtonian physics, which attributes forces like gravity to the shape of our universe. After Newton, a bunch of scientists like Einstein and Robert Hooke patched together the groundwork for quantum theory, and theoretical science is a viable field of study. Theoretical science and quantum theory are quite literally so complex that the human mind cannot comprehend them. So you want to learn about that? Go watch Khan Academy or something. Let's get into specifics, huh? Gravity, in case you hadn't noticed, is pretty important. Without it, Rome would have rose into space, and then everyone would have suffocated. But actually, the Romans wouldn't even get that far. Without gravity, our precious atmosphere composed of CO2 and O2 wouldn't be attracted to the Earth, and no life would be able to form here. So in theory, gravity is literally the reason we are all alive today, along with countless other things. So how does gravity work? Or let me ask a better rhetorical question. What is gravity really? Gravity is relative to the celestial body or bodies you're close to. So for the sake of simplicity, we're going to talk about Earth. Gravity on Earth is a constant force that is pointed at Earth's iron core. This force is pushing down at 9.8 meters per second squared. How hard is this exactly? Well, it's exactly how fast you fall on Earth without, adding an air resistance. This, of course, is only for the first second because if you take acceleration into account, you're increasing your speed by 9.8 meters per second every second. In case you've forgotten me saying it, gravity is relative to the celestial bodies nearby. You remember that? You probably remember me saying I would only talk about gravity on Earth. If you don't remember any of that, just know that I was lying, because the relationship between gravity and mass isn't just important, it's actually interesting. Trust me. Objects of different sizes are affected by the same gravitational force in the same way. However, objects of different masses give off different gravitational forces. That's right, everyone, we're talking about planets. It's a widely known fact that you're lighter on the moon than you are here on Earth, but here's the reason why. Mass. The more massive an object, the harder it pulls things in. However, mass doesn't always mean size. Although our bigger celestial brothers and sisters like Jupiter and Saturn are both larger in size, mass, and by connection have stronger gravitational pull, it is possible for an object to be much smaller than Earth and still have a much higher gravitational pull. The key to this is density. If a celestial body is more dense, it is essentially really scrunched together. It's more matter in a smaller space. Although I could list off planets that are smaller than Earth and still have larger masses, I'd rather talk about a celestial anomaly so dense that it rips a hole in space-time. So yeah, I'm going to be talking about black holes. Black holes are the densest celestial body we've observed in the known universe. Without going into quantum theory all too much, a black hole is created when a point of mass becomes so dense that its gravity begins to suck in everything, even light. The event horizon, or center of a black hole, is thought to have such a strong gravitational force that no force, energy, or matter can escape it. A black hole's ability to suck in light is what gives it its iconic appearance of a distortion in the middle of space with a black hole in the center. The discovery of these super dense space pits can be credited to science such as Stephen Hawking and Albert Einstein. Building out the gravitational studies done by Newton and Galileo. Actually, a really interesting video was uploaded to the YouTube channel Film Theory talking about black holes in relation to the most recent Ant-Man movie. This kind of stuff sounds interesting to you, I'd recommend you go check it out. But, enough with MatPat. This is my show. Hey, quick break here. As I was doing the editing, I thought of a few key points I should probably add in here that don't really fit in with the editing plan, so I'm just going to spew them out here. The main point is that our understanding of gravity seems to be directly proportional to our understanding of space and the universe around us. For example, during ye olde Roman times, they knew about the locations and the colors of many different planets in the solar system, but that was about it. The Romans also knew that things fell when you dropped them. That's about it. However, when the scientific revolution came around, guys like Galileo and Newton pioneered new ideas about gravity and by connection were able to establish that the Earth revolved around the sun. A crime for which Galileo was locked under house arrest for the rest of his days. I'm guessing you all know that the Catholic Church was the one who put Galileo behind bars. And that brings up an interesting point. The relationship between power of religion and our understanding of gravity also seems directly proportional throughout history. We're going to talk about the Romans again because, although good at a lot of things, they were kind of iffy on their gravitational know-how. Whether it was classic Greek and Roman mythology or the branch of the Catholic Church that owned Rome in its final years, religion remained completely unquestioned throughout this time period. However, when we get into the scientific revolution, we get into a whole new world of understanding about gravity and, by connection, the universe. During the scientific revolution, that church actually began to lose followers, a lot of them, as scientists like Galileo were using knowledge of gravity to expose scientific flaws in the Holy Bible faster than the church could lock them up. This change is even more significant in 2K16 because people like Stephen Hawking and Bill Nye and Neil deGrasse Tyson have increased our knowledge of the universe so much more by using gravity to answer the questions hidden in the unknown expanses around us. And because of this, atheism is at an all-time high. I guess you could say that understanding gravity causes a rise in scientific innovation and a fall of religious control throughout history.